Hello everyone, welcome back to my channel. And today we are going to discuss few of the properties on matrices. So I have written down this 4-5 properties down here, and these properties are important to solve the questions that are going to come ahead. So let's begin with our first property that most of you all might be aware now. So let's take up an example of a matrix 1 3 5 2 minus 1 6 3 7 3. So the first property says that the sum of eigenvalues is equal to its trace. So if we find out the trace of this matrix, what it would be sum of its diagonal elements. So trace would be 1 minus 1 plus 3, which is 3. And if we get the eigenvalues as 2, 1 and 0, so if you calculate the sum of these eigenvalues, you will get it equal to its trace. So this is the first property, that sum of eigenvalues is equal to its trace. Now moving on to the next property, which is product of eigenvalues is equal to its determinant. So if suppose I'm just taking an example, this might not be the determinant of this matrix, but if we find the product of the eigenvalues, so in here we got the eigenvalues as 2 1 0. So if we calculate its product, it comes out to be 0, and the determinant of this matrix we will suppose is 0. So if we check that the product of the eigenvalues will always be equal to the determinant of the matrix. So this is our second property which you need to keep in mind. Now the third property is that the eigenvalues of a triangular matrix means it can be an upper or a lower triangular matrix. So the eigenvalues of triangular matrix is always same as that of its diagonal elements. This is a very important property. So if you are given a matrix, suppose as A is equal to 1, 2 minus 3, 0, 3, 2, 0, 0, minus 2, then you don't have to calculate the eigenvalue of this matrix by making that A minus lambda I equation. You can just identify the matrix. So in this case it is an upper triangular matrix. So for an upper triangular matrix, its eigenvalues will be simply the diagonal elements. So the diagonal elements are 1, 3 and minus 2. So the eigenvalues of this matrix would be 1, 3 and minus 2. So you don't need to calculate this by our regular method. You just need to identify what type of matrix it is, and if it is a triangular matrix, then the eigenvalue would be same as that of the diagonal elements. So this is true for both upper and lower triangular matrix. So this is the property number 3. Now the property number 4 is that if the determinant of a matrix is equal to 0, then at least one of its eigenvalue must be 0. So this can be easily verified, as we know that the product of eigenvalue is equal to its determinant. So if any one of the three, as we saw in this case, is 0, then the product becomes 0. Hence the determinant also becomes 0. So at least one eigenvalue is 0, then the determinant also becomes 0, and vice versa. And the fifth property is that eigenvector of any function of A is same as eigenvector of A. This property you might not understand right now, but in subsequent lectures we will understand about this property. Now we are going to look at a table which is very important and it is simple to understand. That is matrix and its corresponding eigenvalue. So let's start. So if the given matrix is A, then its corresponding eigenvalue would be lambda, that we have understood in previous lectures. If the matrix is A dash, that is A transpose, then also the eigenvalue will remain same as it is. Next, if the matrix is A bar, that is conjugate of A, so A bar is conjugate of A, then its corresponding eigenvalue will also be its conjugate. If the matrix is multiplied by any coefficient, then its eigenvalue will also be multiplied by the same coefficient. Next, it is a very important property that e raised to n. So if in the question they have given us to calculate the eigenvalue of a raised to 100, and if they have only given us the matrix A, then we will calculate the eigenvalue of A and we will simply raise it to the power 100, that is lambda raised to n. Next property is A inverse, that is 1 by A. So the eigenvalue of corresponding matrix will be lambda inverse. Next is adjacent of A. So adjacent matrix you might have studied in previous semesters. So the eigenvalue of this would be a little tricky, I would say, to remember, which is determinant upon its eigenvalue. And the next one is I am writing it in the corner. If the matrix is A, then its eigenvalue would be 1. So this is an important table that you need to remember while solving the questions. So please note this down. So this was one. So we will end this our session. So this was some of the few basic properties in matrices. And next we are going to start, in next video we are going to start with Cayley-Hamilton theorem. So before that lecture, I need you to study all these important properties that I have given in this video. Thank you.